Hello everyone, today I'm going to introduce how to naming and join organic compounds. First, let's take a look at how to join organic compounds. So the first step is choosing your formula, whether you decide to draw a structure, condense, or line diagram. The second step is read the name the question giving us. And the third step is follow the instructions in the name. Okay, now let's take a look at our first example. So in this example, we are giving 1,3-dihydroxypropane 2-ONE. So refer to our first step is choosing the formula. So in this case, I decide to use the line diagram to represent this name. So we notice in the main chain there's a propane group. So it should be 3 carbons in the main chain. So we can draw it out first. 3 carbons with 2 bonds in between. And then we notice there's an ONE suffix in the end, which is represent a ketone. And it's located in the second carbon position. So we know ketone have a structure of C double bonded with O with 2 R, 1 in the left and 1 in the right. So which means it's have a double bond with O in the second C position and the first, and then contain 2 R's. And then we can take a look at the side chain, which is 1,3-dihydroxy. In this case, because ketone is in the second position, and it didn't really matter which side we are start, so we can just start from left side in this case. So this is the first carbon, second carbon, and the third carbon. So hydroxy is just another name for alcohol. So we know alcohol is represented by OH. In this case, in the first carbon and third carbon, they all have an alcohol group. So you can just draw it out. So it's OH in the first carbon position. So have a side chain OH in the third carbon position. And this is our final answer. By looking at this diagram, we notice it's a polar molecule, so which means it has a high melting and boiling points. Okay, let's now take a look at our second example here. The second example is 3,7-dimethyl oct 6 ENAL. So oct means there's 8 carbon in our main chain, and En means somewhere in the main chain they have a double bond. So we can just draw out the main chain first, which contains 8 carbon and 7 bonds in between. So 1, 2, 3, 4, 5, 6, 7. 7 bonds with 8 carbon. 1, 2, 3, 4, 5, 6, 7, and 8. And then we notice there's an Al group, Al, in the main chain, which represent the aldehyde. And by looking at our side group, they are just a methyl group. So in this case, Al is the most important. And we can just put the Al either in the left end or in the right end. In this case, I decided to put the Al, which is aldehyde, in our right side of our molecule. So Al is C double bonded with O, with an R, and with an H. So C double bonded with O, with an R attached to the carbon on the left, and also attached to an H. In this case, since it's an H, we don't really have to draw it out. And by this side, the Al is in the right side, so we know our numbers. So this is 1, 2, 3, 4, 5, 6, 7, and 8. And as I just said before, En is represent a double bond, and it's a 6, so which means it's located between, there's a double bond located between carbon number 6 and 7, so it should be somewhere over here. And then by finishing our main chain, we can take a look at our side chain here. So it says 3,7-dimethyl. So now we know in the carbon number 3 there's a methyl group, and in the carbon number 7 also have a methyl group. So this is our final answer. By looking at this diagram, we notice it's also a polar molecule, which means it also have a high melting and boiling points. Next, let's take a look at how to naming organic compounds. By naming organic compounds, we always have to identify the main chain first, and then identify the function side groups, which is our side chain, and then name the compound from most important to least important function groups. Just like this diagram showing here, if we don't really know how to naming organic compounds, in this situation we are giving this molecule, which person should be right in this case? Well, I think the person on the right side, he got it right. Okay, if you're still confusing with this, let's just take a look at our first example. Okay, so in this example, we also, just like as I said, the first step is identify the main chain. By identify the main chain, it's usually the longest chain in the molecule, so it should be this chain 1, 2, 3, 4, 5, 6, 7. So 7 carbons. So we know it should be start with a hat. And then we notice there's a double bond in here. So we know it should be Hept something and En. And then we notice there's a side chain. So over here, so this is aldehyde. Since we know aldehyde is C contain bonded with double bonded with O with another R and with H, but it didn't show in here. And then they also have two methyl group in here. So we can just put represent the aldehyde in Al. So in this case, aldehyde get the top priority. So we know it should be the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, and seventh carbon, from left side to right side. So our aldehyde it's in the first carbon position, so it should be 1 Al, and then our double bond is located between the carbon 5 and 6, so it should be named as Hept 5En 1Al for our main chain. And then we're just naming our side group here. So they have a methyl group in number 2 and the methyl group in number 6. So we know it's a dimethyl. Should be 2, 6, dimethyl. And this is giving us our final answer. 2,6-dimethyl Hept 5En 1Al. By looking at this diagram, we notice it's also a polar molecule, so it also have a high melting and boiling points. Okay, if you still didn't get it, let's just take a look at another example then. So this is another example by naming the organic compounds. By first looking at this example, we will also identify the main chain. So it's this is the main chain. So it contains 3 carbons in the main chain. So now we know it's a prop. It starts with a prop. And it's just single bond in between, so we know it's a propane. And that's 3 alcohol bonded with 3 carbons. So in this case, it doesn't really matter which side we are starting. So we can just start from left side in this case. So 1, 2, 3. And then we know alcohol is represented by Ol. So since there's 3 alcohol, we know there's a tri-Ol. And so it's located in 1, 2, and 3 carbon. So it's propane 1, 2, 3, and try out. And I think this is our final answer. By looking at this diagram again, we notice it's also a polar molecule, which means it also have properties of high melting and boiling points. And this is all the information I'm going to introduce. Thanks for watching and hope you have a great day.